It's now time for me to welcome Edoardo Maria Nencini. Edoardo is a business development representative at Semiotics, and he will share with us his first-hand knowledge of the SAM4 platform with a talk titled SAM4 Predictive Maintenance and Energy Efficiency for the Cities of the Future. So welcome, Edoardo, and the floor is yours.
Thank you very much. Thank you everybody for being here, and thank you to Tondo for the invitation and the Embassy of the Netherlands for the support. Today we're talking about the importance of predictive maintenance for circular cities, and obviously to allow better energy efficiency for especially power plants like in the water sector. So the problem that we see now and the problem that needs to be solved now are mainly two. First one is the serious shortage of skilled technicians. So statistics shows that in the next future there will be a turnover of skilled technicians. So maintenance will lack of technical people to perform maintenance in a good way. At the same time, we see that rising energy costs, rapid digitization, and advantages in AI give us a very important opportunity to take advantages of the situation and improve the development of technologies like SAM4. SAM4 is our technology for predictive maintenance. And we mainly work with water companies. So we believe that actually what Francesco was saying before about the cities being like an organism, it's really important because an organism like human being is made 60% of water. So being able to manage the water in an efficient and optimized way is really important. What makes the technology unique is that we provide 24/7 real-time insights in every asset that we manage, and it doesn't matter what the assets are. We have full visibility over different type of assets, and our algorithm and our technology is able to predict 90% of developing fall with accuracy. And on top of that, we also give critical insights into operational disruption. So companies like M&M or the water utilities can know in advance what is going wrong and can act instead of react. That is also one of the main pillars of our company. And on top of that, we develop a solution that is scalable. Obviously, water utilities manage thousands of assets, and having a solution that is easy to apply and at the same time it doesn't create more problem, but it actually solves problem is what we are looking to work with utilities. What this is important for us. We constantly deliver results. So this is really important for a solution that is, let's say, promising something, because after the promise, obviously, you need to deliver the results. And we have a 90%, as I mentioned before, accuracy. And so we can prevent 90% on unexpected failure. These allow companies to lower their production losses. And at the end of the day, these allow also to be more circular because you save a lot of energy. And on top of that, you save also a lot of resources. In terms of circular economy, thanks to our solution, you can also longer the asset lifetimes. So you reduce the maintenance cost, but at the same time, you also reduce the resources that you need. So obviously better to repair something than to completely change it, also in terms of circular economy. We can get up to 25% energy redemption thanks to our monitoring system. And with our customer, we see that the return of investment, thanks to several factors, can be in just 8 months. So in a full year of service, you can see the results already in the first 8 months, giving us a lot of commitment from utilities and customers. What condition-based maintenance can do for your company, and what are the benefits? Well, from our experience, we see that first of all, we are able to limit visits to pumping station or to assets that are in remote area, and this reduction obviously impacts the emissions and the energy consumption. And on top of that, it also frees a lot of resources that can focus on different activities. We also allow a reduction in cost for maintenance of about 25%, because you know where you need to act. So you don't lose time in finding the problem. You know already what the problem is. You just go there, act on the problem, and solve the situation in a more cost-efficient way. And we are also able to prevent consequences for companies. For example, in the sewage, in a sewage pumping station, if a pump blocks or clogs, the result of the event is that there will be a flooding. So sewage will go around in the system, creating pollution, and also giving fines or also a criminal offense for the company that manage the asset. With our technology, we can prevent that. As I mentioned before, you will have an increase in the asset lifetime, and you will reduce the energy cost. What is important to note is that thanks to technology, as we mentioned before, the maintenance strategies are changing. In the past, and actually even now, maintenance is mainly reactive and planned. So reactive, something's broke, you fix it. Planned, you have scheduled maintenance session where your team goes there, and usually once a year or once every 6 months, they do a check of the asset, but they don't know if the asset is in a good health or if it needs a check. Thanks to the new technology, we are now shifting through a situation where maintenance is based on condition. So you determine the condition of the assets by monitoring it. It's going to be predictive. So as I mentioned before, you know in advance what the failure will be, so you act before the failure is a critical one. And a prescriptive. Prescriptive is really interesting because thanks to the amount of data that you gather from your asset, you're able to understand what are the root cause of the problem that is of the failure that is being developing in your asset. And so you can apply some practices that allows you to solve the root cause and not having the same problem again and again. In the condition maintenance approach, there are 5 different techniques or systems, each one with their own properties. Vibration analysis is one of the most common, together with oil analysis, lubricant, and acoustic emission or thermography. But what Samodics does is it uses electrical signature analysis. Electrical signature analysis is actually a technology that was born and developed in the 70s for the nuclear plants, where it's really hard to access inside the plants because of radiation and also because of other regulatory rules that do not allow people to be close to the plant. So ESA was developed because ESA allows to monitor from the safety of the motor control cabinet asset that can be even hundreds of meters away from the motor control cabinet itself. So this is allow pure remote monitoring of your asset. What needs to be said is that there are a lot of myths about condition-based maintenance. First is the high startup investment, because many people think that in order to have predictive maintenance, you need to deploy a lot of sensor in the field. This will bring the cost up. Actually, with SAMotics, you just need one sensor for each of your assets inside the motor control cabinet. So you don't need multiple access into one application to be able to monitor it. There are also many barriers to adoption, because usually when you need to put something that is quite new into a reality, there are many barriers to that. That's why we develop our solution to be completely integrable inside the infrastructure of the company that is already there. And this allow a simple introduction and a simple development and use for new customer. And even if they have already technology that are in place, our technology is fully complementary with that. So you don't need to change or to completely review your maintenance approach. And also hard to reach asset. As I mentioned before, especially in the water industry, there are a lot of submerged pumps, so pumps that are underwater that needs to pump liquid to another level. And usually those type of assets are almost impossible to monitor in a simple way, because you need to use sensors that are waterproof, and usually those sensors are quite sensible. Our technology, being in the motor control cabinet in a completely safe environment, do not break up and usually are way easier to install, especially for pumps that are underwater, because you don't need to lift the pump up and apply the sensor on the pump itself. How SAM4 works. As I mentioned before, SAM4 uses a high-frequency sensor installed in the motor control cabinet to measure all the three phases of current and voltage. In the edge, so on-premise, the gateway perform an initial processing of the data, and then it encrypts the data, so data are safe and cannot be read by anyone outside the organization, are sent to our SAM4 cloud via connectivity, Wi-Fi, 4G, Ethernet. In the cloud, that's where the magic happens, because our algorithm of artificial intelligence are able to process the incoming data 24/7 and to detect and classify any variation from the health patterns of the asset. And this allow our expert to pick up the notification from the algorithm, make their analysis. So it's not only AI that make the analysis for us, but we also have a pool of technicians that analyze again the indication from the AI, and just after that communicate to the customer what is going on and what they need to do to avoid the further failure. And communication can happen in different ways, usually via our platform or via email. In case of really emergency situation, we also pick up the phone and give directly a call to our customer. One of the example, one of our success story is the Yorkshire Water one. Yorkshire Water is water utilities from UK. And the challenge there was that they manage a very big territory. So they don't manage only a city, but they manage the whole region. So they have a lot of they have a lot of assets that are in remote area. And usually maintenance team has to do 70,000 trips annually to this pumping station, mainly because there are clogging. So they need to go there and unclog the pump. This in a year is a highly cost operation, because you can imagine that 70,000 trips with a distance of around 300 kilometers in diameter is a cost, and it's also an impact to the environment. On top of that, when the clogging happen, if nothing is done in a very fast way, you will have a pollution event. In the UK, pollution events are really serious, so they get fines, very high fines, and they go to the news, and there is a lot of public attention on this. So Yorkshire Water came to us because we are able to monitor those pumps remotely, and we are able to prevent clogging with our anti-clogging feature. So basically in just 2 minutes, when a pump clog, we are able to detect it and communicate to our customer. This, as you can see on the left side of the screen, yes, it allows a 50% reduction in the trip. More than 10 pollution events were being prevented. And and 10% of energy consumption has been reduced. There's also an explanation from Simon Rhodes, that is the business transformational manager of Yorkshire Water, that basically sum up all that I just mentioned. With condition-based maintenance has been a game changer. In fact, remote monitoring saving us time, money, and energy otherwise spent on non-value adding site visit. So thank you very much. And if you would like to have more information about SAM4 and SAModics, please reach out to me. You can find all my contact details there. Thank you very much.
Thank you. Thank you, Edoardo.